Alright, hello again, and, sorry about this, but I've already tried to record this once today, and, well, it was an hour-long recording, and it ended up not turning out. Part of the audio cut out at about 18 minutes, so, here I am again, and so, there's good news and bad news. You don't have to probably sit through an hour-long video now, but the bad news is I have already done a whole bunch of stuff, and I've already written all the code, so basically I'm just going to go over everything here on my notes now that I've now written, so it should be easier to pay attention and figure this one out. And if you want me to do it this way from now on, I will gladly do that. So today we will be learning about structs, which are basically structures, comments, dynamically allocated memory, basic pointers and warnings, and the Sizeof function. So, oh, sorry. So, last time we made an array, a function that allowed us to create an array, and with up to 100 values, and also allowed us to access those values and things. Another thing that I just remembered I went over was if statements more in depth, or more like Boolean statements and operations, which I will also need to go over. So, first of all, let's start out with, oh yes, and so let's say we wanted to make this program, though, be able to do something like a point, a 3D point. We wanted it to be able to hold more than just one value, or maybe values of different types, such as a float, an integer, maybe a string. Actually, that's another thing I'll teach about now that I might have more time. We'll go through char pointers, which are basically strings of characters. So, yes, so let's start with the structures. So as you can see here, I declared two structures while making this the first time. And basically, a structure is a special variable type that allows you to create a variable of different stuff. It allows you to create, basically it allows you to store more than one variable in a variable. I know that kind of sounds weird, but that's how you would do it. So to start out here, we have our point 3D, and oh, that's right. I also went over. 1 second here. I also went over advanced variable declaration, so you can declare a variable as x, y, and z. Oh my goodness, I just messed that up. But yes, you can declare variables of the same type right in a row just like this. This declares the variables x, y, and z all at the same time, and you can assign them values like that as well in this fashion. You can do that anywhere, but you can do it up here. Okay, another thing that I just remembered I went over, and sorry for cutting in on this, is functions. I went more in depth into that. Just kind of tried to clear up some things from past, because this is actually the last beginner video. So yeah, once you've gone from this, and understand it all, you've graduated from beginner to intermediate, or yeah, intermediate. We'll get into the structure later, why it's like that. So yes, and down below, okay, since I actually got rid of it, you can see that you can declare a variable now with this pre-created variable type that we have just made. And so down here we've declared a variable with our variable type, and basically you access the data inside by putting a dot and then the name of the variable you want to access inside of it. So we can access x, and we can say it equals like 67, and then when it equals 67 you can do that with y and z as well. And that's about it for structures. So and then I was just about to say how did that pass, but it's all okay. These right here are comments, and let me actually move this. You use these when working with other people because you probably aren't going to make a video or anything or be able to explain it to other people, and also just to help yourself. But it basically allows you to put human-read sentences anywhere in code, and the compiler will just skip right over it. You can put whatever you want here, and it won't change anything. But basically, to start a comment, a single-line comment, you put 2 slashes like this next to each other. To make a block comment, which allows you to press enter, and have a multi-line comment, which is also useful for cutting out code, and it can be used for like finding errors in your code and stuff. Like you can get rid of code to see what code is working and what code isn't. You use the block comment, and basically that's a slash with a star, and then just same slash and same star, but in reverse order, and that will end it. And so that's the block comment. Let's see here. Next, we will go over dynamically allocated memory. Now, in this program, we were able to do up to 100 values, but let's say we wanted to do any number of values and save as much memory as possible. Basically, I'll have to go over pointers at the same time. But basically, we use dynamically allocated memory. So, excuse me, in C++, you use the new, I don't know, operator or whatever. We use that to dynamically allocate memory, and basically you put new, and then whatever type you want to declare, and then it can be an array of some size. And in normal arrays, when you declare them, you can't actually put a variable in this, but for dynamically allocated memory, since it's dynamically allocated at runtime, you can put any number inside of it. In this case, the reason for this one is so that if we access the array before we actually properly initialize it, it won't throw an error back at us. And you need to do this, otherwise pointers are very dangerous. This is what A is, and all new basically all new memory should be assigned to a pointer. And so what a pointer is, let me go into that before I go too far. A pointer is a basically variable. It's a number that points to a location in the computer's memory. And pointers can be very dangerous if you don't know what you're doing and you like pass in your own values and stuff if you don't have them allocated. Basically, you always want to give a pointer some value from something in your code or something that you know you can grab from someone else's code. You never want to give it its own number. You can grab the number from it and give that to a different pointer, which is just absolutely fine, but never give it like a constant number, because you can never be sure what memory is being held there, and it can ruin stuff. So yeah, make sure it's from your own code is the only thing the pointer ever points to. So yes, so that was just kind of a something to keep us from errors. Right here, this creates a, see, you already knew that. Because of my amazing comments, I don't use those as much as I should. Also, let me go over something here. I changed this a little bit. This used to be, I'm trying to think here, average array, and now it's access value, which allows us to access a value from a point in our structure of point3D from our array of stuff that we have. And I guess I could go into that right now. Do I have, let's see, I went over all that. Oh, before I go on, oh no, this will be perfect. So as I go on, let me show the changes that I made to create array. So basically, every time you allocate memory, if you allocate new memory to that same pointer and don't keep track of it, it's lost forever and actually can completely get lost on your computer and cause what's called a memory leak. Basically, a memory leak will take up your computer's memory and will make it useless for the computer to use. While now there is ways to get rid of memory leaks, and that's to restart your computer. That's the only way I know how to get rid of memory leaks, because the operating system allocates it, your program forgets about it, and it never gets deallocated. So what you need to make sure you do before you just completely lose something that you've pre-dynamically allocated is you need to delete it. And if you created a dynamically allocated memory that wasn't an array, you don't need that. But when it is an array, you definitely need that right there. And that tells it to delete it, and it tells it that it's an array or a long chunk of stuff, and that gives it what it needs. Okay, and then this, what is this? And then this is, you get the number from the person of how much, and you can then make a new list. After you've deleted the old list, you make a new list, the size that you need. And N is declared in global scope, so that's up here. That's another thing I'm going to go over is scope. Just hold on a second. So N can be accessed from anywhere. We also changed the if statement to say if it's less than 0, then it's an invalid amount and must be over 0, because now we aren't limited to just 100. And this is something that I changed. It basically, you enter all the values of x, y, and z, and now we get into our little function. Now, I kind of already went over return types, but I just think I should go over it again. So, main has a return type of int. Basically, this means that when you say return, you have to return a variable of that same type. And then, basically, if something calls it, you never want to call main anywhere. Okay, this is very important. Never call main anywhere. It is supposed to only be called at the beginning of your program. So you can call maybe another file's main, but never call the main that starts the whole entire program ever again. Okay, but I will do it for demonstration's sake. So let's say you call the function main, and you have an integer to catch this. We'll call it the catcher. And basically, this will give you whatever main returns. In this case, main only returns 0 because we aren't catching any errors or anything and returning anything else. But yeah, that's how that would work. Like I said, you can return anything, and this will actually return it. You can return a variable that maybe you've done something with, and return it through your return statement, and that will help it out a lot. So anyways, yes, that is that for that. Now let me go back to set point. So we actually have declared the floats x, y, and z down here, and now would probably be a good time to talk about scope. So for variables, scope is something you need to pay attention to. You can never declare variables of the same name in the same scope. So if I had an int or in a similar scope. So if I had integer x, y, and z, let's just say I had that, it would throw an error because I'm redeclaring them down here. Variables can only be declared once in the same scope. Now, global scope goes over everything on this file. Whereas there's also... Oh, sorry about that. Where was I? Right, so you can't declare variables of the same name in the same scope. However, function scope is hidden from every other function. Which brings me to another useful thing for pointers. Pointers can be used to pass variables from function scope into a different function scope and be allowed to be edited in that function scope. Which brings me to passing in variables. So this right here are the types of variables you pass in. Now, as you can see, I didn't use my little trick, and that's because you can't. You must declare the type of each variable and put a comma in between it for everything. This is just how you call a function. So as you can see here, we have A, which is actually in global scope, but I think I did it this way to show you the purpose of maybe throwing it in there, because now you can see that we actually can use array to edit these variables, and had this been declared in function scope, it still would have been alright. Position is the position that we want to access. Float x is obviously x, y, z, etc. So yeah, that's just how that works. And as you can see, we use that stuff, and yeah, it's pretty self-explanatory from the last one that I did on arrays. Pretty sure I did arrays last time. I hope so. Anyways, I think that takes care of all that stuff. Now, let me see if I can find... Okay. I think I went over... List array is basically the same as last time. This time we're just listing every single value of the points. So, yeah, that makes sense. And then something I want to go over in this one is the size of. So, let's say you want to know if, like, because we have it enter an array position, the array position would be like what point we want to access in the array. We want to make sure it's not greater than or equal to n, because remember, the highest number you can put in a array for location is one less than the number of elements you wanted it to contain. I hope that made sense. I think I worded that correctly. And it can't be below 0 again. So this is kind of where I went over everything. So let me just quickly... So pretend that this is a new if statement over here. Let me go over the conditions first. So let's say we have a variable, and basically these are the different tests you can do. You can do less than, greater than, less than or equal to, greater than or equal to, not equal to, and equal to. So those are the different tests you can do. These all return booleans when they finally finish, and you can actually do these anywhere with the boolean function. So, like, let's say you have a bool Earl. I don't know why Earl. And you have your variable v, and you can do a test on it. So, like, if v is greater than 10, and then whatever this condition comes out to, it's put into here. You can also, I could also put this into here, and whatever a boolean value that gives back, that is what Earl would equal. So yes, that's a thing to know, is that these always return booleans back. So the actual symbol for not is an exclamation point, and so you can like not a boolean, and it will return the reverse of whatever you're testing for. Normally it's good to just reverse the test, but if you ever wanted to do a not on it, that's a good way to do it. So you have the equals to and all that. For, like, now if you have two conditions, like you have variable v is greater than 10, but you also wanted to test for something else, this is the sign for or. I think I've gone over that before. Haha. And this is the sign for and you can put two conditionals together, and that will and or them. Basically, it's putting two booleans together, anding and oring them. Or basically means if either one is true, or if both are true, then it's true. And means only if they're both true, then it's true. And there's an exclusive or, I forget how to do it, but it might be 2 carets. Don't take my word for that, but yes. So that might be exclusive or, and that would be only if one is true and one is false. Then it would be true. So that's how that all works. And here we actually have a premature return statement, because if this value is not valid, we don't want it to run the rest of our code, so we immediately return from this function and do not do anymore, because it would cause errors if we allowed it to continue. We then say enter a position X, Y, or Z, and this is actually testing. This is an actual text test handling, if that made sense. So yeah, I think I've gone over everything else on here. So now it's just this part. As you can see, I've used the equals operator on this char, and basically a char stands for a character. Now, let me go over something. A char, so this is a basic char, uses single quotes with one letter, and that can even be a space, any kind of character, okay? I mean, any kind, any symbol you can think of can be a character. This is a string, and these are saved as char pointers. So we can call this like a string. A string. Now, a cout will actually take this string and say, oh yeah, that's fine to output, and it will actually output this normally. You can save strings like this and everything, and you can access strings, which I might go over later in once we get into like operations and stuff. But yeah, you can assign this value anything. Like, let's say you're using ci sin. I think if you use a char pointer, it will actually output the entire string put in, whereas if you entered a string with using only chars, it would continue to output each character to a separate char variable. So just something to think about when you're working with everything. Okay, but since we are wanting only single characters, and that's the only thing they should be inputting in, is we just use char c for the character, and that's all good. But now we want to test for which location it is. I should probably put, if it's none of those, then what you really should do, and I'll leave this up to you if you want to do it, it's a nice little test of your programming skill, and I've given you enough to know how to do it, is if it's none of these, it should come back up. Okay, if it's none of these, it should come back and like start from this point again, right here. This point. Okay? So like, and it should restart from there. Let me show you how to do this in a case statement as well, just to like bring out really what the case statement can do. So we switch C, and we do a case X and a case X, and this will actually do the same thing as if it were this. Okay, and then you put your code that you want for either one of those, and that is how that would work. And then you would go, and then you would break it because you don't want it to continue, but then you could do a case Y and a case Y, and then you could put your code here that you would want it to execute at that point. I'm not going to do it that way, only because for the purposes of this code, it will work fine the way that I have already done it. But that is a nice thing to re-emphasize what I mean by what the case statement can do and why you have to put the breaks in it. I think I can actually kind of just get rid of my notes now. Anyways, a char cannot be easily set to lowercase or uppercase. You have to test for both. So this is obviously saying if C equals capital X or C equals lowercase x, then output the X position at the position that they put in up here of the point, at the position they put up there of the X variable, and create a new line after that. I think I've gone over all the code now. Here, let me just go slowly through the code, just so you can see it all, if you want to try this yourself. Oh, one other thing is you're going to need to kind of declare this variable so that you don't get errors right here. And it needs to be it needs to be exactly the same as what you have down below. If you ever did want to stay away from having to like declare all of them, you could do this. Okay? And that would allow you to not have to declare it above. But if you're wanting to keep your code all below where you're going to like run it from, all the functions below where you want to run it from, you have to put it back down here. One other quick thing I want to run over, let me make sure, okay, is other stuff. Variables. So variable naming. For anything that's a like class or structure, you should start it with a capital letter. For anything that isn't, you should start with a lowercase letter, including functions. But I'm okay because this is global scope. And actually, for any variable in global scope, you should capitalize the entire thing. I didn't do it in this case because sometimes you just don't follow conventions. Conventions are there to be recommended practice, and it's things that everyone understands, but it doesn't mean you have to. Another thing is, if you're like creating multiple words, since you can't have space is in a variable name, is to like uppercase each start point of each word. Or another thing you can do is an underscore, which is if you're all capsing it, you use the underscore. You can use a combination of both and stuff, and it's just fine too. But yeah, so that's something you can do. You can't start a variable with a number. That would cause an error right there. And so yes, but you can have numbers in it just as long as it's not the first thing. So I couldn't have a 3D point. It has to be a point 3D. I guess another thing to quickly note is that actually by calling using namespace std, it brings everything from std into this global scope. Just thought I'd throw that out there. So, yeah. Let me go slowly down through this code again, so that you can try it if you want. And I think I'll show you how it runs after I get through all this. If you think I left out anything, or there's some sort of code I didn't explain thoroughly, tell me. I'll make a quick video response, or we're back. Sorry for I did something that I shouldn't have. Let me actually just pause this so that I can do it. So, let me see here. We'd want to do G++, and, well, actually, since it's done, I should be able to do this. I called it points. Oh. What did I? Oh, goodness. Exit? I did something wrong there. This is not a good time either. Okay, I'll be back. Here. So, let me just make sure I type in this right. There we go. So, we'll create an array of 5 numbers. And right now, I'll just enter all the same number. And we are going to want to access number 2. So I'll make sure that it has special numbers in it. And I'll make sure there are some other special numbers other places. And yeah. And of course we always need one of these. I try to go as many digits as I can, but I can't always remember pi. Okay. So let's access a variable. Oh, that's right. I forgot to reverse the new line. Oh well, if you want to do that, make sure you reverse that. That's very important. By reversing it, I mean reverse the slash. Use the other slash for the new line character. Um, so, let's see here. For now, I'm actually going to show you what happens if you put in an invalid number. You get a value not valid. However, I should be able to access it through use of for should be available, as in it is. Wow, really, is it? It's that old, huh? Well, this was debug stuff I was using as of Sizeof, and I'll have to quickly ramble through that. So let's say we want to get the Z position, and there's our 3.1459. Now let's say I want to access a different variable, at position, just anything that's not a 1. 2, we'll get the Y value, and you see we get 67.5, which is also right there. So yes, and now to show you that you can actually do over 100 numbers now. 2003 is a lot of numbers to do, and that's why I'm not going to do it. But you could technically just sit here and go through all 2003 numbers, but we aren't going to do that right now. So yeah, that's it for this video. I hope you enjoyed, and next video I think we'll actually be getting into classes, so look forward to that. Probably just a few more advanced pointers and some intermediate pointer stuff, like this kind of pointer, and yeah, so look forward to that. And I might be making videos on a daily basis now. So yes, until next. Okay, so I realized I forgot a few things. You already saw this program, and well, let me just go over those few things. So I was going to say I was going to discuss Sizeof, and I also said I was going to talk about this. So let's get to it. Sizeof, which is typed out like this, will get the size of whatever is put into it in bytes. So you can put a variable. You can put, well, let me do it. You can put a variable. You can put a variable type, or a class, which we haven't gotten into. It will return all those bytes. You can also put in an array, and it will return a static array. Let me make this clear: a static array, and it will return that size in bytes. If you put in a pointer, it will basically always return 8 bytes, which is a long. Yeah, so I'm sure you can see why this wouldn't work for dynamically allocated memory. The reason for this, why it can't do this, let me make this easier on myself, is because it's something that the compiler replaces with constants as it goes through. And since dynamically allocated memory is not constant, and because of the nature of pointers are not constant sizes and stuff, they're just locations in memory, it will not be able to return correct stuff, and so it just returns the size of the variable, which is 8 bytes. So, what do you have to do? Well, here I kind of have an example, dynamic array, and basically it holds the array, which, if I remember correctly, a void pointer can be anything. So it could be an integer pointer thing. It can be, anyways. That's something good to know, is a void pointer. Void anything else I don't think is anything, but a void pointer is very important. And well, I think maybe a void variable is actually something. And then you have the size of your array. There are other things to do this, such as there are other classes, and I'll get into those probably by the end of the intermediate. We'll have a little session on commonly used classes. and libraries, but yeah. Anyways, that's all I needed to share. So until next time.